Dart skill presents ratio. A ratio compares two quantities of similar type. For example, we could say the ratio of girls to boys in a class is 1 to 3, also written as 1 TO2 3, and also written as a fraction 1 over 3. And it doesn't mean that the class has got only one girl and 3 boys, 4 in all. It only means that in every group of 4 kids, there's only one girl and 3 boys. You add another group, so that adds one more girl and 3 more boys to the class. So the ratio doesn't give you the actual numbers. It gives you an indication so that you could compare, okay, this class is heavy on boys as compared to girls. Often in educational institutions, we talk about the student to teacher ratio. And we have something like, let's say, 10 to 1 or something. It doesn't mean that the whole institute has got 10 students and only one teacher. It means that for every group of 10 students, on an average, there's one teacher. So if there are 20 students in the institute, there would be 2 teachers. If there are 100 students, there would be 10 teachers and so on. And like I said, it can also be written as 10 to 1 or 10 over 1. They all mean the same thing. And because ratios can be written as fractions and fractions can be reduced to their simplest forms, ratios can also be reduced to their simplest forms. All you need to do is just rewrite the ratio as a fraction and keep reducing it. There are a couple of more things you want to know about. A, in ratio the order matters. Therefore, if we say that the ratio of boys to girls is 3 to 1, it means that in a group of 4 kids there are 3 boys and 1 girl. The order in which we write this does matter. And then automatically it implies that the ratio of girls to boys is going to be equal to 1 to 3. If you write this as a fraction, this is 3 over 1. And if you write this as a fraction, it's 1/3. And 3 over 1 is not the same as 1/3. So the order does matter. And B, in a ratio, the first number is called the antecedent. Let me write that down. Antecedent. And the second number is called the consequent. So this is the consequent. Time for us to look into a couple of examples. Express the ratio of 15 to 24 in its simplest form. To express a ratio in its simplest form, you can simply write the ratio as a fraction and keep reducing it, and in the end, when you have the simplest form of the fraction, convert the fraction back to the ratio form. So this is going to be equal to, the greatest common factor between 15 and 24 is 3, so divide 15 with 3, divide 24 with 3. So we have a 5 on the top and an 8 on the bottom. And this cannot be reduced. This is the simplest form of that fraction. And therefore, the simplest form of the ratio is going to be 5 to 8. As easy as that. Let's do another one. Divide 120 rand in the ratio 2 to 3. So let's say all of this represents 120 rand. 120 rand from here to here, from start to end. Now this should be divided in such a way that there are 2 parts on one side and there are 3 parts on the other side. And they obviously all have to be equal parts. And the question is, where do we make this cut? Now, if you look at this picture, it's pretty obvious that 120 has been divided into 5 equal parts. So what is the length of each part, or what is the numerical value of each part? To find that out, all you need to do is divide 120 with 5. Now, where are we getting that 5 from? We are getting that 5 from adding these two numbers up. So you pretty much add up the antecedent and the consequent. Sorry, that's supposed to be a 2 plus 3. I was about to write a ratio there. And this is equal to 120 divided by 5, and that is equal to 24. So there's a 24 in each one of these. And the moment you find that out, the rest is just a piece of cake. Because on the 2 side you have 2 of these 24s that make it 48. 48 on the 2 side, and the rest, that is 120 minus 48, that's one way of finding that, or you could just multiply 24 with 3. Either way, the answer is 72 on the other side. So then the 2 side is 48 rand and the 3 side is 72 rand. That's how you would divide 120 rand in this ratio of 2 to 3.